We're on worksheet number 1, review worksheet, problem number 3. This is an actual AP exam question. We're given the graph of F. So this is the graph of F. And then we're told F is a semicircle and 3 line segments. And G is actually the integral from -3 to x of f of t dt. Now, just looking at the setup, that G is the integral from -3 to x of f of t dt, what theorem does this make you think of?
First fundamental theorem.
Second fundamental theorem of calculus, right? So SFTC, it's not SFTC because SFT, of course, requires the derivative of the integral, right? Okay, but it should at least make your brain think that way. Like, ooh, I bet we're going to have to do some SFTC in this problem, right? Okay, hey, look at this. Part A, find G prime, right? Okay, so G prime, that's the derivative of this integral. Everyone use SFTC for a moment and see if you can figure out the value of G prime. It should take you literally the time it takes to write it. So what does G prime equal?
F of x.
Good. Okay. Did you all get f of x? Only one person answered, but yeah, you plug in the top limit times the derivative, which is 1, right? Minus 0. So G prime of x. Hey, look at that. G prime of x is just f of x. Right? Look at that. So G double prime of x, what does that equal? F prime of x. Just taking the derivative of both sides. Any questions on that? No, we're all okay there? All right. Now we have to find G of 0, G prime of 0, and G double prime of -1. The hardest of these 3 is the first one, G of 0. Because G prime is just f, and G double prime is just f prime. But G is this, right?
Ooh.
So, if we want G of 0, that's the integral from -3 to 0 of f of t dt. Don't let it bother you that the input for f is listed as a t value here and an x value here. For this problem, t and x are interchangeable. So it's okay if you call it f of t or f of x because they both actually represent the same values. So don't let that freak you out. So anyway, so we have the integral from -3 to 0 of f of t dt. How are we going to find the integral from -3 to 0 of f?
You just look at the thing.
Look at the thing.
Graph.
The area.
Someone said it.
Graph.
This would be the area under the curve from -3 to 0. Okay, it would be, remember an integral, definite integral represents area under the curve? Okay, so what shape is this? It's a trapezoid, right? Now, you can either do area of a trapezoid, or say you're taking a test and you're like, I don't know, area of a trapezoid, what do you do?
Triangle.
Triangle or rectangle, just split it up, right? Add them together. Everyone take a second, find the area of that region.
And Mrs. Grace?
Yes.
How do you know that G double prime of x is equal to f prime of x?
Well, do you understand how we got the G prime is f?
You plugged in the x and then the
Times its derivative of 1. Yeah. And then you plug in that times its derivative, which is 0. So you end up with f of x. Just take the derivative of both sides and what do you get? There you go. Okay, so you should have gotten, let's see, if I do trapezoid, I get 1/2 times the height, which is 3, because it's sideways, times the sum of the bases, which are 2 plus 1. So I get 9/2. Got a thumbs up. Any questions on the area? There will be some geometry on your test on Monday. Okay, so next we want G prime of 0. Well, let's see. G prime of 0, that's the same thing as F of 0, right? Hey, what's F of 0? It's 1.
1.
Right, just get it straight off the graph. Now, G double prime of negative 1, that's equal to F prime of negative 1.
The slope
Hey.
of negative 1.
So we want F prime of negative 1, which is, in other words,
The slope.
the slope at negative 1. And we're going to take a second and figure out the slope of the graph at negative 1. I'll get negative a third. Good. Moving on. Okay, so now we're on part C. Find all values of x from negative 5 to 4 where G has a relative max. Justify your answer. You could make sign lines for this. I personally don't make sign lines for these problems because the problem with sign lines is if they're not labeled really clearly, people get confused between the G's and the F's and the G primes and the G double primes and the F primes and the F double primes. So what I do is I do this. I say, I actually write my answer with a blank. And I say, all right, G has a rel max at x equals, and I just leave some space, because why? Why would G have a relative max? Because not it,
Because the function.
because
The derivative.
the derivative of what?
Of f of x. No.
What do we want a relative max of?
G.
G. So what needs to change? G prime. Okay? So G has a relative max at x equals blank because G prime changes from positive to negative. If you didn't have any of this problem and all you were handed was this question, this would be an appropriate statement to write, right? Okay, so now what you have to do is figure out where does G prime change from positive to negative. Well, what is G prime equal to?
F of x.
It's equal to F.
So
So we want to know where F changes from positive to negative.
So where it crosses the x-axis.
Yes, but it has to change literally from above to below. It has to go from positive to negative. There's only one value, and what would that value be?
3.
Very good. So this function, G, has a relative max at x equals 3 because G prime, which is the same thing as F, changes from positive to negative at that point. Did I see a hand up? Elizabeth, did you have a hand up? Do you have a question? You sure?
Why is it a negative 4?
Because negative 4 is
Because
from
that's
negative
where it
to
changes from negative to positive,
Oh. My
right? So that would be a relative min, right? Good, good questions. Does everyone understand that? Plus, the other benefit of doing it this way is then you always get the points for your because statement, even if your answer is wrong. Always write the because statement. Okay. I'm going to skip D and I'm going to do E first. All right? So we want to find all the values of x where the graph has a point of inflection. So G has points of inflection at x equals blank because why? How do we know when G would have a point of inflection?
When f double prime of x.
Stop saying F.
Oh, sorry.
What function are we talking about?
G.
Guys, this is incredibly important. You can't write F by accident because F in this problem has meaning, right? So you know how like a lot of times we get you by writing a function with g of x, and if you write it with f, I'll just like take off a point. You can't do that here because f has significance, so just writing f by accident is not allowed. Okay, you gotta stick with g. So g has points of inflection because why? G double prime
Changes sign.
changes sign. Now, what is G double prime equal to? F prime. So what we're looking for is where F prime changes sign, which is where the slope changes, right? So where F changes direction. So F prime is the slope, right? So the slope here is positive, negative, negative, positive, negative. Where does G double prime or F prime change sign?
-3.
At -3, because it goes from positive to negative.
1.
1. Does it change sign at 0?
No.
No. Even though there's a sharp turn there, it's negative and it continues to be negative, right? Okay, so then it changes sign at 1, and then it changes sign again at 2. All right, talk to me. Does that make sense? Okay. If you need to do these with sign lines, that's absolutely fine. Just be very, very clear when you make your sign line. If I was to make a sign line for G prime, I would also label it as F. I go 5 to 4, and then I would say, all right, so we are negative, and we are positive to 1, and we're still positive after 1 all the way to 3, and then we're negative. And I would cut it at 1 because that is a critical number. It's 0 right there, even though it doesn't change sign. So anyway, yeah, so positive to negative. Anyway, just be careful about it. I like to do it just by the think about it method for these. It just makes it easier for my brain. Okay, now we got to find absolute min. Absolute minimum occur at either a what or a what?
Critical value.
Yes, an endpoint or a critical value, right? Okay, so the absolute minimum of G would be at the endpoints or the critical values of G, which are where G prime is 0 or undefined. So the absolute min has to occur at one of these numbers, because that's where G prime is 0 or undefined. Now here's the thing. We're finding an absolute min. If you want to make your life easier, you can ask yourself, all right, if you do make a sign line, it does make it easier for this. There are only 2 values of x where an absolute minimum could possibly occur. Looking at the sign line, and especially at the arrows, what are the only 2 places that could actually be a minimum?
-4 and 4.
Very good. That's quick. That's quick. It took first period quite a while to get that. All right. So, Riemann says -4 and 4.
But -4 is not.
But it's critical value. Absolute min could be either at an endpoint or a critical value, right?
Negative.
Okay. Now, why couldn't it be a -5?
Because your slope is negative.
Yeah, because after -5 we're decreasing, right? So obviously this can't be the lowest point if we go lower after it. So we're decreasing after -5, so that can't be the min. Then we increase all the way up to 3. This is a max. There's no way it's going to be a min, right? And then we decrease to 4. So it's either here or here. So now, when we have to test, right, this is absolute extreme on a closed interval, so we test our critical numbers and our endpoints by plugging them into the original function. So we need G of -4 and G of 4. How do I find G of -4? What does that equal?
The integral of G.
The integral from -3 to -4 of f of t dt. So we'd have to set up the integral from -3 to -4 of f of t dt. Oh no, we're high to low. We have to reverse the limits. So this is actually equal to, oh, so sorry, negative the integral from -4 to -3 of f of t dt. How am I going to find the integral from -4 to -3? Yeah, it's the area, right? From -4 to -3. So it's that area. So we would have negative 1/2 times 1 times 2, or -1, not because it's below the x-axis, but because the limits had to be reversed to go from low to high. All right, g of 4. This is a fun one. Now we have the integral from -3 to 4 of f of t dt. So that means we are going from here all the way to there. So we need to find this. Hey, we found that in the first part, right? This, and this, and this, and this. I want everyone to take a minute and see if you can find this cutesy area. Anyone have a strategy for finding it?
Ooh, times 2 of 1.
You subtract the area of the rectangle by b.
Beautiful. Yeah. This is not the area of the circle or the semicircle, right? It's one of those, remember those fun geometry problems you were given, right? Where you had like, oh, a square and a circle, find the area of these little outside parts,
Those are
right?
always in the SAT.
Really?
Yeah,
Oh.
a lot of those.
You get a lot of those?
Sprouts.
Oh, good. So we can call this SAT prep.
No.
Already took the SAT.
Oh well. Okay. Yeah. So anyway, so think of this as like a rectangle, right? And then you have to subtract out.
Yeah, we stuff the sucks of the ACT.
Okay, that's not nice.
I just wanted it on camera.
I'd be Chris from
All right. So you have to subtract out the semicircle, right? So it's the rectangle minus the semicircle.
How come for the definite integral of g of -4 you use -3?
I use -3 here too. Because that's our definition.
Oh,
of t,
okay.
Right? Oh, yeah.
I would just-
So that's where -3 came from, because
Okay.
that's the function way it's defined.
Okay.
Okay. So this is 9/2 plus, what's the area of the rectangle?
2.
2. Good, be confident. Okay, minus the area of the semicircle,
Pi r.
what's r?
2 pi, no, pi r squared.
Yes, what's r?
Okay, 1.
1, right?
So pi.
Area on camera, area of a circle is pi r squared, okay? Area, so the radius is 1, so the area of the entire circle would be pi. Is this an entire circle?
No.
It's half of a circle, so this would be pi halves. And then this little triangle has an area of a half, and this little triangle has an area of a half, so I do plus a half, plus a half,
No, plus a half minus a half.
plus a half minus a half, because that one's below the x-axis, they end up just washing each other out. Okay? So this integral is actually equal to 9/2 plus 4/2, so 13/2 minus pi halves. I need the absolute min, so I have to know which one is smaller, -1 or 13/2 minus pi halves.
-1.
-1.
Very good. Because pi is around 3, right? So this would be around 5, positive 5. -1's way smaller. And remember, your answer is just the minimum value. So it's just that -1. You guys should have more space on your paper, right? 'Cause I squished everything up. If you didn't make a sign line, you are stuck testing every single critical value. Yeah. Yes.
When it says justify your answer, how do we justify it?
The test is your justification. For absolute extreme on a closed interval, it's where, when you do your test of all of your endpoints and critical numbers, you can narrow it down as long as you show that you made a sign line to check where the minimum values had to occur.
Do you want to use the words like?
There are no words. There is no because statement for
Okay.
absolute extrema, not on a closed interval.
Okay.
Okay? So if you used words like because g prime changes from negative to positive, you would be very wrong.
Okay.
Okay. That would justify a relative min, not an absolute min. Alright, we're moving on. It's time to have some fun with Riemann sums. So, but I don't like this one. So we're going to go to a different worksheet. Okay, we're going to go to worksheet 3, number 3, but I am going to change the function. Because this is presented as a PVA problem, and I want you to understand that you don't have to do this in the context of PVA. It can be any context, and it will be a different context on your test, so I want to do it with a different context. Now, here's the thing. When you have an amount and you take a derivative, you get a rate. So I did it this morning in the context of, I used the exact same data, and we decided to make it a hot dog eating contest. So this is going to be in minutes. This is going to be a really long hot dog eating contest. So it's going to be a 20-minute hot dog eating contest. So this is time in minutes, and then this is not velocity. We're going to call this h prime of t, and that's going to be hot dogs per minute that people are eating, okay?
The speed of the hot dogs going.
Yes. Hot dogs consumed per minute. Maybe we could say that it's 2 people, but it's probably just 1 person. On those hot dog eating contests, they shot. They really go, right?
Yeah.
Yeah, so anyway, okay, so we're going to say this. Now here's the thing. If you started with a bunch of hot dogs and you took the derivative, the rate of change of the hot dogs being consumed, you'd get hot dogs per minute, right? If you take the definite integral of hot dogs per minute from 0 to 20, you would get the total number of hot dogs consumed in those 20 minutes. So if you go from hot dogs per minute and take the antiderivative, you're back to hot dogs. All right, if you start with hot dogs, take the derivative, you're at hot dogs per minute. If you start with hot dogs per minute, take the antiderivative, you're back at hot dogs. Does that make sense? For velocity, velocity is actually rate of change of position. So velocity is measured in feet per second. If you take the antiderivative, you get feet, right? So that's why that definite integral of velocity is total number of feet traveled, right? Rate of change of position is velocity. Antiderivative velocity is not its position, but if you take the definite integral, it's distance traveled. All right, so anyway, same thing here. So the antiderivative of hot dogs per minute is total number of hot dogs. So when we do estimate the integral from 0 to 20 of h prime, when we do this, these values are going to be approximations for the total number of hot dogs consumed in those 20 minutes. Does that make sense? So whenever you have a rate given to you and you do a definite integral, it's the amount of whatever that is, right? There was one where it was, we did one problem, it was a snow shoveling problem. And it was like, so-and-so can shovel, 14 cubic feet of snow per hour. How much snow did she shovel from, 0 to 5 hours, right? And then you just do the definite integral and you get the total amount of snow. So, anyway. Okay, so if we want to do this using 6 trapezoids, this table is very different from the ones you've been given in the past. What makes this table unusual?
Different width.
The widths are not uniform. So you can't just do a b minus a over n for width on this problem, because every width is different. So I'm going to map out our 6 trapezoids. We have to go from 0 all the way to 20, and the nice thing is there are 6 intervals to deal with. So I'm going to kind of put, like, our first trapezoid would go from 0 to 2. Our second trapezoid would go from 2 to 5. Does that make sense? And then 5 to 8, and then 8 to 11, and so forth. So let's write out our approximation. So the integral from 0 to 20 of h prime of t dt is approximately, every trapezoid area has one number in common. What is it?
It's width.
No. One actual
Oh, 0.
number that isn't
1/2.
constant. 1/2. And whenever you take an area of a trapezoid, every single time you have to multiply by a half, so you can put the half out front. Area of a trapezoid is the width times the sum of the heights. What is the width of our first trapezoid?
2.
2. And then the two heights would be 5 plus 6.5. What is the width of the next trapezoid?
3.
3. And the two heights would be 6.5 plus 7. What is the width of the third trapezoid from 5 to 8?
3.
3. Do you guys see where we're getting the widths? We're subtracting the t's? Okay. This would be 3, 7 plus 8.5. All right. What about the trapezoid from 8 to 11?
3.
3 times 8.5 plus 9. What about the trapezoid from 11 to 17? What's the width?
6.
6 times 9 plus 8. And then the last one, 3 times 8 plus 7.5. And then you would have to put this whole shebang into your calculator and figure out the answer. Something tells me that it's going to be in the hundreds.
So what if they did have uniform widths, then you would have just.
You could just put the width out front
Okay.
and then set all the heights. Yes?
What's like the general notation for area, or like the trapezoid again?
Area of a trapezoid. Area of a trapezoid is 1/2 times the width. I'll show you. Times the width times the sum of the heights. This is not what you learn. Here's what you learn. When you're a kid, you learn 1/2 times the height times the sum of the bases, right? So like, that's your height. That's base 1, base 2. But for us, our trapezoids are all turned sideways. So the width is actually the height, right? And then the heights are the bases. Okay, 3 left-handed rectangles, not 6, 3. So we're going to go every other and do 3. So we're going from 0 to 5, 5 to 11, and 11 to 20. What is the width of our first rectangle?
5.
5. It's going from 0 to 5. We want a height. It's a left-handed. These are your two heights to choose from.
5.
Which one do we pick?
5.
The 5, because it's on the left. Plus, remember, area of a rectangle is just width times height. What is the width of the second rectangle? 6, because it's going from 5 to 11, so it's 6. What would be the height that we would use?
7.
7, because that's the one on the left. What would be the width of the next rectangle?
9.
9, and what height would we use?
9.
9. So there's our left-handed, and you would have to figure out the answer. Right-handed, the widths would all be the same. Everyone take a second and figure out the 3 heights that go in there if you were to do right-handed rectangles. Okay, so what's the first height?
7.
What's the next height?
9.
What's the last height?
7.5.
7.5. Do you all understand where we're getting the numbers? Middle. 3 middle rectangles. Again, the widths are still the same. But now, and middle are often called midpoint. Don't let that concern you. We know that this isn't the midpoint. Just go with it. Okay? What is the height of the middle of that rectangle?
6.5.
6.5. What about the next one?
8.5.
8.5, and the last one?
8.
8. Does that make sense? Okay. Average velocity, so in this case we're going to call it average of rate at which they are eating those hot dogs, right? The average rate of hot dog consumption from 0 to 20. So using 6 trapezoids, so it would be 1/20th times the integral from 0 to 20 of h prime. Well, the 1/20th stays. This whole thing, you found this with 6 trapezoids in which part? Right here, in part A, that little subpart Roman numeral 1, right? So whatever you got in that part, you times it, times it by 1/20 or divide by 20, right? And that would give you your average rate. Average rate of hot dog consumption, and it would be in hot dogs per minute, right? So these would be total number of hot dogs consumed over those whole 20 minutes. This would be the average rate that we consumed them in, hot dogs per minute. How's that sitting with you? Is that okay? Awesome. All right, so tomorrow we're going to continue on.